we spent quite some time on this one slide so that you could understand it very well, right? So weld arc is shielded by granular flux. Granular means powder form, grain, right? Granules, powder. Granular flux that is fed into the weld zone by gravity flow through a nozzle, right? The hopper and the nozzle. The hopper is there and a nozzle is there, and your flux completely covers the molten metal and prevents weld spatter and so on, right? The process can be automated. So this is the whole thing. You are starting from here and you are moving down there, and this whole system is on certain wheels so that it can move along. It can move along, right? Of course, there will be a certain maximum length that can be done in one go, but that length, whether it is 1 foot or 2 feet or 1 meter or 2 meters, whatever is the capacity of this plant, after doing that, if there is even more welding, then you will have to start again, right? So, but every electrode will not be used up and so on. The electrode will be coming continuously through the wire, right? So this is called submerged arc welding. Submerged just because the whole welding area is submerged by the powder form or the granule form flux from the hopper, right? From the hopper, powder is falling, of course, exactly on the weld area. Exactly on the weld area. So as you move along, the weld area is submerged in a way by the flux which is coming from the hopper in a powder form. So it is called submerged arc welding, and this is now very good quality because there is no human error, right? If the machine is moving by its own, the distance is fixed, the speed is fixed, the angle is fixed, isn't it? Remember, the electrode was to be roughly at a 45-degree angle. That angle here is already fixed. The distance from the weld to the tip of the electrode is fixed once, and then it will remain, and the machine is already set at a fixed welding speed. So because all these three are done by the machine this time automatically, therefore in submerged arc welding the quality of the weld will be very good. Of course, this will be required only where the weld length is large. If there is a small weld length, you have to do only half a foot, only 1 foot, then you cannot set up this whole machine. Then manual arc welding, shielded metal arc welding will be the best one. Or if it is in a vertical position, for example, or welding is to be done at a height, this can be done only if both the plates to be welded can be placed on a table or the floor, right? But if you can have this horizontal welding, right, on the ground welding, and the welding length is long, then this is a very, very good method. Next one, gas metal arc welding. Gas metal arc welding, GMAW. Gas metal arc welding. Earlier, it was called MIG welding. MIG. MIG welding. Metal inert gas. You see here it is gas metal arc welding. Earlier name was MIG. Remember that, please, right? Metal inert gas welding. Now, even in the name, there is a big contradiction. There is gas and there is arc. So you should stop me if you are in the class. You say, doctor, what is this name? I mean, is it gas welding? Is it electric welding? Right? So yes, your question, if you were sharp enough, would be a very automatic question. That you see, gas arc welding. You see, gas welding, you use oxy-fuel, oxyacetylene gas, not electricity to generate the arc. But if it is arc welding, then what is the gas doing there? We will just explain it to you. We will just explain it to you. The name is right. It is not a wrong name. The weld area is shielded by an external source of gas. Remember, in shielded metal arc welding, the weld area is shielded by the flux on the electrode. In submerged arc welding, the weld area is shielded by the flux, continuous flux in the hopper. But when we do not use the coating on the electrode or the powder form of flux, rather for shielding the weld, we pressurize a gas in that area, then it becomes this, that you are doing arc welding, but for shielding you are using a gas rather than a solid powder, right? So it is gas metal arc welding. It is an arc welding, but you are shielding the metal by using a gas, right? Deoxidizers, materials which remove oxygen. So deoxidizers are present in the electrode to prevent oxidation, that is inside the electrode, and this method is suitable for both ferrous and non-ferrous metals. Remember from your material science, all metals like iron and steel, which have the property of magnetism and so on, are ferrous metals. So there are thousands and thousands of steels and cast irons and so on. All metals like aluminum alloys and so on, which do not behave in a magnetic manner, are non-ferrous metals. So almost all the metals in the world you can divide into two groups, ferrous metals and non-ferrous metals. So shielded metal arc welding, gas metal arc welding is good for all of them. The process is rapid, versatile and economical. Not as economical as shielded metal arc welding. Shielded metal arc welding is lower in cost compared to all other electric arc processes. But this is higher level because we will continuously need an inert gas. That is why the original name MIG, M-I-G, metal inert gas. You see, if you pressurize a gas there which already contains oxygen or which does not stop burning, then oxidation will still happen. But if you send an inert gas which envelopes the welding area is now covered by an inert gas, right? So now inert gas is there, so oxidation reactions cannot be there. So this will cost. You will have to have an inert gas with a high pressure cylinder, and that will be coming into the weld area. The rest of the welding is going on. Okay, so this is gas metal arc welding or metal inert gas welding. Here now the schematic, right? The schematic and so on. So let me first show you this, right? You have the welding machine, right? Which is in parts. This whole thing is suppose the welding machine, right? So this is the welding machine. This is the welding machine. Here they are saying 110 volt supply or whatever voltage it is there. This is the shielding gas. This is the shielding gas. So there is a cylinder of shielding gas, and therefore there will be regulators and controllers and so on, right? And there is a source of the wire. There is a source of the wire which is just continuously coming like in the previous submerged arc method. So there is a spool of wire, remember. So the wire is coming from here. The wire is coming from here. So the wire controller, motor, feeder will be there, right? Together with this. So gas is coming from one line, wire is coming from the other line. And of course from the welding machine you have to do, connect the workpiece and the ground and so on, right? So this is as we said, the wire is coming. So wire feed drive motor, and feed control. Inside there is a control system, right? So this is the whole feed control. Then from here there is a gas out, gas in, gas out. Gas has been taken out. And there is a gun control. Gun control means the wire will be controlled and so on, right? So the wire will be fed, the gas will be fed, and now this is the welding gun. So right, so the arc will be here, and from here the wire will also be coming, and the shielding gas will also be coming, right? So the wire will keep on melting and you are doing the welding, and the shielding gas will cover the weld area as it moves along, right? So this is the whole setup. In more detail, if you just want to see the weld area, so this is the base metal. We started welding from here and we are moving to that direction, right? So this is the whole gun. Inside there is a line for the shielding gas. There is a solid wire electrode, and there is a current conductor. There are three things there. The electrode is there, which is coming from the wire spool, and this is being burnt up and used up. So there is a second piece which is just for conducting the current. This will not burn, this will keep on burning. So there is the current conductor, there is the solid wire which is the electrode, and this is the shielding gas, and all of it is inside here. So from this nozzle, then the wire is coming and the shielding gas is coming. So wire guide and contact tube, nozzle, the shielding gas, the arc is here. So here it is melting and burning, and it is covered by this whole cloud of gas. So oxygen of the air cannot intervene. And once you have moved out, of course, this much welding is solidified, and there will be a slag on top of it which you can remove and so on, right? So this is gas metal arc welding, previously known as MIG welding, metal inert gas, right? So GMAW or MIG. And the expertise of the welder in GMAW should be more than in general shielded metal arc welding. Shielded metal arc welding already requires a very high quality skilled worker, right, welder. But if that welder is to be doing gas metal arc welding or MIG welding, then the skill level should be higher. Normal arc welder generally cannot do GMAW, but whoever is trained for GMAW is already a very good arc welder also, right, normal arc welder. So this is, right, the first method, remember, was shielded metal, the second was submerged, and the third was gas metal arc welding. Let us continue. Flux core arc welding, right? So flux core arc welding, similar to gas metal arc welding, just the one that we did just now, but the electrode is tubular and filled with flux. Do you understand? The electrode was a wire previously. The electrode was a wire, solid wire, right? And the flux was coming from a shielding gas from a gas cylinder. Here this time the electrode is like a tube, is like a pipe. So it is hollow in the middle. So outside it is the electrode material. Inside the hollow, the shielding gas is coming. So therefore it is flux core arc welding, right? Or inside the hollow there is a powder, right? Like in submerged arc welding, there was a powder or granular flux. So in the gap there is a tube. The electrode wire is a tube, hollow. So in the hollow you either fill a solid or you can connect a gas. It is up to you, right? So let us see the schematic. This is the welding gun or tube, right? Current carrying guide tube, right? Insulation, extension tape and so on, that is okay, insulation. Inside, if you see here, powdered metal, vapor or gas forming materials, deoxidizers and so on, right? So here in the tube, this tube is the electrode. This will later on melt, but inside the tube you have filled some powdered metal, generally, which will also burn, and it will become gas or vapor, and it will deoxidize the weld area. So this is it. Now you have the base metal, right? You have the base metal here and there, and you have the welding area, and once you do the welding, on top there is the molten slag, and after some time there is the solidified slag. So if you are coming from here, you keep on melting. Inside there is the welding, outside there is the cover. That outside cover is the solid, and right, you will do the welding. So this is the schematic. But inside the solid wire, there is a powdered metal which will burn and become like a gas, right? And it will come continuously. This tube will come continuously, not single piece, continuously. So because the flux material is in the center, so it is called flux core. Core means inside, right? Flux. So this is called flux core.